Welcome to LWM channel. Subscribe to our LWM channel to learn computer networking. From now on, new videos will be uploaded regularly on our channel. Today's agenda. What TCP IP model? History of TCP IP model. Compare TCP IP model and OSI model. Advantages and disadvantages of TCP IP. What TCP IP model? The TCP IP model is a four-layer model that divides network communications into four distinct categories or layers. The model is often referred to as the TCP IP stack. The four important layers are the application layer, the transport layer, the network layer, and the link layer. Let's now talk about TCP IP model that's similar to the OSI model. It's called the TCP IP model. It's made up of two protocols, as you can see. The first one is TCP, which stands for Transmission Control Protocol, and it runs over IP, the Internet Protocol. Together, TCP IP is the base for the Internet. Unlike the OSI model, which divides network communication into 7 layers, the TCP IP model divides it into 4 layers. And this was developed by the US Department of Defense. This is what the TCP IP model looks like. We have 4 layers. History of TCP IP model. The global system of interconnected computer networks, the Internet, makes use of TCP IP to communicate across networks and devices.Transmission Control Protocol. Internet Protocol, TCP IP, as the name suggests, are protocols, i.e. systems of rules. The protocols, in this case, are communication protocols which define rules, systems, semantics, and synchronization of communication and possible error recovery methods. The TCP IP suite was introduced by the United States Department of Defense, DoD, with a vision to ensure and preserve data integrity as well as to maintain communication in event of major wars. TCP IP was first introduced in 1973. Later in 1978, it was divided into two protocols, TCP and IP. Finally, in 1983, TCP IP replaced Network Control Protocol, NCP, which was the standard mechanism of communication used in ARPAnet. Compare TCP IP model and OSI model. Let's compare this to the OSI model. The TCP IP first layer at the bottom is the network access layer. The second layer is the Internet layer. The third, we have the transport layer. And finally, we have the application layer. So the first two layers of the OSI model, which are the physical and the data link layer, are combined together in the TCP IP model, which is called the network access layer. The network layer of the OSI model is called the Internet layer. The transport layer remains the same, and the last 3 layers, session, presentation, and application layer, are combined into one layer called as the application layer. The difference is primarily in the structuring of the layers, but from a functionality standpoint, they're pretty much the same. The OSI model is meant to be a reference model, while the TCP IP model is meant to be an implementation model. Advantages and disadvantages of TCP IP. The advantages. It is an industry standard model that can be effectively deployed in practical networking problems. It is interoperable, i.e., it allows cross-platform communications among heterogeneous networks. It is an open protocol suite. It is not owned by any particular institute and so can be used by any individual or organization. It is a scalable, client-server architecture. This allows networks to be added without disrupting the current services. It assigns an IP address to each computer on the network, thus making each device to be identifiable over the network. It assigns each site a domain name. It provides name and address resolution services. The disadvantages. It is not generic in nature. So, it fails to represent any protocol stack other than the TCP/IP suite. For example, it cannot describe the Bluetooth connection. It does not clearly separate the concepts of services, interfaces, and protocols. So, it is not suitable to describe new technologies in new networks. It was originally designed and implemented for wide area networks. It is not optimized for small networks like LAN, local area network, and PAN, personal area network. It does not distinguish between the data link and the physical layers, which has very different functionalities. The data link layer should concern with the transmission of frames. On the other hand, the physical layer should lay down the physical characteristics of the transmission. A proper model should segregate the two layers. Thank you very much for watching carefully.